OEM is a vehicle manufacturer. This is an example of the core functionality of our dashboard. Here we can see analytics page with different signals on the right and a map on the left side. So there is a specific ride of a vehicle. This is around Zagreb, capital in Croatia. And we can see different points on the map that are correlating to different signals values on the right. So we have seen something like brake, state of charge, and battery values. So this is primarily used for our R&D engineers. And as I said, we are a platform, so we are supporting not just one OEM, we are supporting multiple OEMs. So it means that we need to have some sort of user management. This is how our current user management looks like. On the left side, we have some user information and user group informations to which this user belongs to. On the right side, there are a couple of permissions. And what's the interesting part here is that some of these features on the right side on the bottom can be then fine-grained to vehicle level. So, for example, we can say that when we enable vehicle analytics feature for a specific user, we can say that for some vehicles this can be true, but for some others we don't want. And why is that? Because for different engineers, we really want to handpick in specific scenarios which in which feature scope we want to allow to see or to execute these vehicles for. And this worked really well until we worked on a specific secret project. And in this scenario, our product owner came and say, okay, guys, can you please restrict a number of signals that the user for this secret project can see for this vehicle or for a group of vehicles? And our system wasn't built for that. And because it was very rigid, we ended up doing a quick solution that was more of operational side than from the technical side. We renamed the signals in the way that they were written in Croatian, so nobody could understand what the signal meant. But we needed to have some long-term solution. So we wanted to restrict some sensitive signals to not be viewed by all users that has an enable feature for this user, but just to non-sensitive signals. And our system wasn't built for that. So we ended up in research. So what our options are. But first, let's start with our connectivity platform needs. So this is how our user management looks like at the moment, and it's implemented at the moment. So we have a user that can be a part of the group, and both a user and a group can has an access to a specific permission or permissions. And for some permissions, they can be applied to different vehicles. And this works okay. But as I said, we had this secret project that needed additional requirements. And in the center, the requirements are described as vehicle sensor data can be grouped by sensitivity. So there could be 3 groups of sensor data, like unrestricted, all sensors without GPS. GPS is the most sensitive data, or only non-sensitive data, so without speed odometers and any other stuff. Then we also wanted to group the vehicles into fleets. So if there is a new vehicle coming up, we didn't want to copy-paste all the rules from previous vehicle. We want to apply existing rules that a fleet of these vehicles has. And the third thing we want to implement is local admins. So if we have different OEMs on our platform, we want to give these admins, in our case, these are OEM admins, rights to do whatever they want with the vehicles and users they are assigned for. And our system wasn't built for that. So we started with the research and figuring out what are the all options that exist in authorization world or access control. So the most prominent one and the most used one and the simplest also is role-based access control. I think that most of us at some point in time stumble upon this approach. So we have roles like general law, payroll, IT role, etc. And all of these roles have one or more permissions attached to it. And this works great when there is no huge amount of rules or permissions we want to manage. So we can attach then one or multiple roles to user, and then it works really okay. But when we go into fine-grained authorization or we want to achieve more granularity, then we ended up doing multiple roles, maybe with some sub-roles, and this whole thing becomes very messy. And in the end, it's very hard to figure out what roles we need to add, how these roles are connected, and can we make the right approach with roles. So there is another approach here called attribute-based access control. And in this approach, we are adding attributes to users and to resources. Resources are basically items that we want to protect for a specific use case. In our use case, the most prominent resource is a vehicle. And then based on the attributes attached to the users and resources, in some cases also we can use environment attributes like access time or IP range or data location. And based on these attributes, we are generating permissions. And upon result from this permission, we are allowing a user to access a specific resource. So and also now we are using Keycloak as our identity and access management, so for both authorization and authentication. And Keycloak is a standalone software or provider that is open source and can be used by anybody. And in Keycloak, everything in authorization part of it, everything goes around the permission. So we can, with permissions, we are defining can a user access a resource through defined scopes. For example, can a specific R&D engineer through policy and define permission execute a specific command that is a scope that applies to a single resource or vehicle. And also we can use user groups and stuff like environment variables. They are attached to the policy. And this works okay in a scenario where there is one resource type or when there are not multiple resource types. For example, in our case, we want to have vehicle fleet. And then we have two resource types, and then we are either duplicating this whole schema or complicating a lot. And also, when we look upon these graphs, it looks on the first sight, it looks a little bit complex to understand. It takes some time to understand what's really going on here. What would be great here is if there is a possibility to represent what we want from a real world into a software world. And there is a solution. It's called graphs. So with graphs, it's easily to represent a topology or a network of different users, resources, and relationships going on with these resources and users. So in graphs, we have nodes. They can be on any type, and relationships between these nodes. And graphs are not a new approach in software world. So we have it like in Facebook, friends and friend of friends, and what these friends are liking, or where these nodes are located. And also we have existing databases that are also allowing us to model these graphs like Neo4j. So this is not something new, but in authorization world, it's just has started. So if we wanted to represent our Rimac case in graphs, it could look something like this. So we have a user and we have a vehicle. These are two main parts of our representation. And user can be an admin or a member of both user groups and OEM. Vehicle is again assigned to a specific OEM and can be a part of a vehicle fleet. And relationship between both user groups with users and vehicle fleet is around different features. So in this use case, we have feature analytics and feature configuration. One interesting part here is that we can also say, okay, specific OEM is licensed for a specific feature. It means that this OEM paid for this feature, and this OEM can only use this feature. More about it later. But what's the point here is that we can easily model whatever scenario we have in a real world into a graph representation. And this way of working or access control is called relationship-based access control or next-generation access control. As I said, this is a fairly new approach, so the industry is still not straight on what is the best naming. So we have these two namings currently that are doing that are describing the same thing. So to compare these three approaches, role-based approach is very easy to set up, but it becomes very complex to understand when topology evolves and there are a lot of rules. Yeah, granularity, then granularity is always a problem, and then you need or either a new approach or it becomes very hard to maintain and to extend. So another approach is attribute-based control, here it takes more effort. It's not suited for really fine-grained granularity and authorization, but and it's somewhat complex to understand. But again, it's not so complicated to set up, and it can fill its purpose when you need more of it, but you don't need to go so to the low levels. And our approach here that is most suited for, so the end solution that we wanted to go with because it best suits our needs is relationship-based access control. So the setup takes some time here. So it's not so easy to set up the whole thing, but it provides really granularity, and it's very easy to extend. And graphical, what's most important, graphical modeling enables anybody to understand the topology. So it's not just that developers can understand what's going on. It's easily understandable for non-developer person to figure out upon the model what's going on here. And then we went to see what are the providers on the market. So the first provider that I already mentioned is Neo4j. It's graph database, maybe the most prominent one. And it's based on nodes and relationships with different attributes. So here we have an example of 4 nodes and the relationship between them. And if we want to find a specific node in this topology, we are using their language called Cypher. Here there are two examples of this query. And if we take a look, so there is a match person with relationship likes to another node technology. And the end result here is Jennifer. Also, we can use for this matching attributes from the node itself, like, okay, find me a node with a type person and an attribute Jennifer with a relationship called likes, with the relationship with attributes likes that goes to the node type technology and attribute type of graphs. So this language is very powerful, and it can yield really interesting results. But in the end, Neo4j is a database, and we wanted to find out what is the best authorization provider for us, because authorization provider gives us more than just a database to model. It also goes with defined policies, authorization policies that we want to use, and Neo4j doesn't support that. So our next solution provider that we encountered is Auth0 FGA, or fine-grained authorization. It's based on two to three things, so models and tuples, with evaluation upon these two. The thing about authorization FGA is they are central based upon, I would say, the central node. In these examples, you can see there is a GitHub node in the center of the picture, and there are different nodes related to the central node. So we have repository, organization, user, and team. And around these nodes, there are different relationships that are describing how these nodes can be connected. So on the left part, we can see that a representation of the model we are seeing. So I will just go a little bit into details here. If you take a look on the type repo repository, it has two relationships. One is admin that can be self-defined, and the other one is maintainer that can be self-defined, or it can inheritance the stuff from the admin. So if we go to the bottom part on the left side, these are the tuples. So tuple is the way of describing paths between relationships of two nodes, and it helps us to build authorization model. So for example, we said that here user Charles is connected to team open FGA as a member of it. And then on the second tuple, we say, okay, team open FGA and that are defined as the core members are connected to repository open FGA as admins. But also as a maintainer is defined, he can also inheritance the admin. So admin can inheritance the same privileges as a maintainer. So the user Charles is not just an admin of this repository FGA, he's also maintainer. So it looks a little bit complicated, and I think it is. This is not the real representation of graphs that we wanted to have. And this way of thinking is a little bit, I would say it's strange on the first. So it takes time to understand what's really going on here. So this was something that we didn't want to have. And the second thing is this solution also doesn't provide us a possibility to get resources that match some criteria. So for example, we want to get a list of vehicles that satisfy some condition for specific users, so we can then show the list of vehicles for that user. So we end up with our end solution. It's called scaled access. So it's based on model policies, and again, evaluation of these models and policies. So here we can see a model of what we are trying to do. And if we go back a little bit and see, this was our initial idea of how it should look like. It's pretty much the same as we managed to do in scaled access. So this is really a great thing. As not just it's not just for developers easy to understand what's going on here, it's also easy to understand for others. So again, we have a user, and for this user, we can define different relationship between user and other resources in this graph, and every node here can have a different attributes. For example, here user is selected, and we defined an ID for this user. So to quickly compare these solutions, and I think every solution has potential and its implementation or use case, I would say. So Neo4j is great for graph representations, and it's been here for a very long time. It's very powerful from query side, and you can easily get a list of resources. And I think anything you want to do with graphs can be easily done in Neo4j. But what's missing here is queries and authorization rules that needs to be done by clients. So there is one aspect of the solution that we would be missing if we went with Neo4j in authorization, for authorization purposes. And then one of it is compliances to different regulatory aspects that we want to achieve, as we needed in that scenario to build that for us. So the other solution, Auth0, it's great for evaluating an access to a specific or multiple resources. Still, it's in beta, so it's not full in production, and it's missing some sorts of graph that we wanted to have, like, for example, listing. But again, from a policy side, it has its tuples, and it's easy to define different rules. And in the end, scaled access, it's great for fine-grained authorization. It's out there also for some time, so it can be trusted upon. It has a really good support for graphs, and really interesting thing is that policies are defined in Rego language, and Rego language is a standard language for defining authorization rules. So let's see how one policy looks like. So policies can be in scaled access written both in graphical and in this codes part or Rego language. So here we have a user that belongs to a specific group. So user is a subject here, and a group is a resource. And we in this policy, we can see that default outcome is deny everything, and then we allowing if user condition is satisfied. And in user condition, we can see that if subject ID or user ID is the same as user ID that exists in the resource, or in this case, user group has user ID somewhere in it, and the subject type is a user, then this user can read the group or properties of that group. And here goes a little bit more complex scenario. So this is a representation of what we are trying to achieve with our fine-grained authorization. So on the left side, again, we can see that all outcomes are by default denied, and that we want to allow an access if either of these two conditions are satisfied. So there must be a starting point of a user and end point of vehicle. It means is user and vehicle. And the second one is user has a direct relationship to vehicle via analytics. Or the second condition, so this is or, Again, user and vehicle must be satisfied, and user has relationship to vehicle through groups and fleet via analytics. So if either of these two conditions are satisfied, then this permission will say it's okay for user to access this feature of vehicle. So we can see on the bottom right that these are transitions through the node types on the through the topology. So, for example, user can be an admin or a member of a group, and if these groups is connected to vehicle fleet via feature analytics, and the vehicle fleet has an ID that is the same as the resource of the vehicle that is part of this fleet, then it's okay to allow this user to see a feature analytics of a specific vehicle. So with this, it's easily to define complex scenarios, put it in one place, and then use it all over the system. And we are attaching different policies to topology, and then using the same permission for any use case we want. So to conclude the presentation, we started this change from a secret project that changed our requirements, and product owner that wasn't satisfied with our response that we cannot do it in any time soon. So we ended up with the research to see what are our options out there, and found out that with graphs, we can easily describe what we want to do, and decided to go with a scaled access solution. And as takeaway message, I would like to say that in most of the cases, we want to find a solution that is not enforcing world to fit into our framework, but that we want to build a software model that is a representation of the real world. So to use the right tool for the right job, in our case, relationship-based access control for managed fine-grained authorization. So yeah, thank you for listening. I think we can skip to the questions.
Thanks, Luka, for that presentation. There was one question that came in while you were presenting, and that's what is your language stack for connectivity platform?
Okay, so connectivity platform is built upon two big interfaces. One interface is vehicle based, and the second one is client based. So because these are like two different worlds, I would say. Vehicle based is more IoT, and here we are using protocol called MQTT, and in combination with Kafka, we are using Java or Scala, or Java and Scala for our stack here. And on the client side, we are using GraphQL as a way of protocol between clients and our APIs. And here we are using Node.js with TypeScript and SQL databases. Yeah, I would say that's most of that.
Thank you. Questions? Anyone?
Hello, everyone. I have one. My name is Adnan. So, real quick question. So, you managed to connect, how you call it, scaled access with the keycloak, right? You're managing access roles and policies in scale access, but you still use keycloaks for authorization of the application. Am I right? Or you replace the keycloak with a new tool?
Yeah, we will ditch keycloak to a new tool. As for authentication purposes, we are switching to Auth0, and for authorization purposes, we are switching to scaled access, and these two works really nice together. So then we are going away from the keycloak self-managed service to cloud providers, to fully cloud providers.
Okay, thank you.
So there was a question I saw, can groups belong to other groups? Yes, but in our use case, we didn't want to do it like that. But yeah, you can easily, if you say that a group can has a relationship to the same node, then yes, group can belong to the group. But that was not in our use case at the moment. I'm not aware of any requirement like that. How do you sync resources with scaled access? Okay, so scale access consists of three main things. So first is configuration panel. I showed it. Maybe I can. No. So yeah, in this panel, you can see the. I'm not presenting. Okay. I'll try to explain. So from configuration part, you're configuring the model and you're setting the basics for all others. So policies and models are defined either through APIs. It's better to define through APIs, or you can do it manually through graphical interface. Then the second thing is populating the data into these models. And so we are saying, okay, we have these users, these vehicles, these groups, these features, etc. And these users are belonging to these groups, these vehicles are belonging to these fleets and to these OEMs. That's the second thing. The third thing is that, okay, we'll connect our backend services to the scaled access and then say, okay, we want to execute upon this, or we want to evaluate this permission upon this user and these resources. And then there are upon permissions that exist and models that exist and resources that exist on their side, they are defining if that's correct or not, or it's allowed or not. And the second thing we can ask is, okay, which resources satisfies a specific permission. So again, upon a specific policy, we will get results as a list of resources. So mostly it's API, but for starting, we can use graphical interface to better understand what's going on. And in the end model will always be a graphical representation. Okay, maybe I can screen.
Sorry.
Oh, sorry. So I just wanted to. So this is the dashboard of scale access. So we have the main model here, and then we have different policies here, and then we can see a specific policy, how it's defined in a code, or if there is a possibility to see it in a graphical representation. And the data thing, this is a fairly new thing. So I haven't checked it yet. So this is a feature added in the past few months. But yeah, these are the three main things that you can see from graphical representation. Okay.
A question about the roles. How does it work? Does the product owner here decide on predefined roles? And then when there are new roles, you're developing new roles, or do you have a user interface where you can actually create new roles on the fly?
Okay, so we are not using roles in that way. So we are defining, okay, if we go to, just a second. Just to show it better. Okay, I'll share the screen again. Okay. So this is how our user management looks like, and here is the most important part. So we are defining how it currently looks like. So we are defining for specific user what features he has an access to, and for specific features we can define with what vehicles are allowed in this feature scope. So for example, we can apply for data format management, this is configuration. This user can for a data format configuration feature, he can able to configure specific vehicles that we define here. So it's all about configuring what the user can or cannot do. Also, he can belong to a group, and then this group can do the same. Also, for this group, we can say, okay, for analytics feature, here are the list of the vehicles that any user that belongs to this user group, he can access these vehicles for analytic purposes. So we are not using roles in a like basic way. So we can know, maybe we have an admin role that is like has everything allowed, but for every other scenario, we are using permissions. Not sure if I managed to answer.
Right. Thanks. But when for example onboarding a new customer who has bought a new car or onboarding a new OEM, who is handling this?
Okay. So what we are doing is, for example, we have connected user management. If this user is incoming from a specific OEM that has domain, for example, I know Rimac Technology or something like that, we are connected with their user management provider. So in automotive world, it's mostly Microsoft Active Directory. So we are connected to their user provider. It could be Facebook, it could be Gmail, it could be Azure, whatever. And when the user logs in using OAuth, it will contain predefined some attributes. And upon these attributes, we can initially put it in a specific group. So in this scenario, we have this user group that all the people from Rimac will automatically be a part of. And when there's a new user that logs in and it's from this domain, it has automatically all the stuff that is defined with these user group policies.
Thank you.
Any more questions? I have a question. How was your first webinar? Are you satisfied?
Well, it's strange not to speak to a real person, like in person, but yeah, I'm satisfied. It's a little bit harder to figure out how people are reacting to the presentation itself without the visual input from the other side.
Okay, guys.
The accents are good.
Okay, good.
Thank you.
Any more feedback then, or questions from anyone here?
Well, I just want to say, great presentation. When I saw it published, it really kind of immediately made sense. Like ACL with graphs, and it kind of immediately made sense to me. And I just wanted to see a bit more in details, and I didn't even know that they were actually providers, because for me also the first thing that came to mind was Neo4j, and then implementing policies on top of that programmatically. But I actually didn't know about that there were some providers already.
Yeah, so that was the same thing for us. We at first we were like, oh, Neo4j, it's so great. We can do anything with Neo4j, and then we figure out, hey, but there is even better thing out there, and we don't need to care about building our own services that will handle permissions and certifications, because in the end we are a platform, and we want to have some sort of certifications we can give to the end customers that will be going to use our platform or are already on our platform. So we definitely end up using end solution here because it simplified our life a lot. And then again, there are other things that are either developed by, for example, authorization providers like invitations via email, acceptance of invitations, and stuff that can be like, will be definitely built in the future. So I would say the best solution here is to just try to find out what is the best tool for your job in the end. Okay.
Okay.
So we can wrap up.
Yes.
Thank you.
Thank you all for coming and for listening to me. I hope you hear something new that maybe you could use in some point of your development or careers. And yeah, have a nice rest of the day.
Definitely.
Thank you.
Thank you.
Thank you, Luka, for your presentation, and thanks everyone for joining today. Have a nice afternoon.
Thanks.
Thank
Bye.
you. Bye.
Bye-bye.
Bye-bye.
Luka, jūs jau tu?
Yes.
All right. I neki su ljudi još ostali na kolu, a čekam te da ti se zahvalim. Eto, nadam se da ti je bilo ok.
Hvala. Hvala
Kako
na
ste?
opciji da imam prezentaciju. Mogućnosti.
Nema na čemu. Je li ovo vaš vice na
Je.
kolu? Ok, neću njega remove. Znači, priključili se i oni na kraju.
Bili su ti pod M2M soba.
M2M, jel da? Aha, ok, skontala sam, crcao na crna. Ništa, za sljedeći put Teams, ugasi notifikacije gore od backend crew.
To se tek poslije shvatio. Još je bila opcija kao kad sam prezentirao disable notifications. Ja rekao, valjda to će biti dovoljno, ali dobro.
I super si bio, hvala ti puno. Podijelim s tobom link i eventualno neki dodatni feedback iz onoga što sam ja shvatila, bilo je ok, mada znaš da ja nisam tehnička osoba.
Ok, hvala ti.
Čujemo se.
Bye.
Ćao.